Hey y'all, it's Mr. Smith again. This is percent rate video number 3. So in video 3, the problem we have the amount of water remaining in liters after X minutes is modeled by the equation y equals 450 times 0.84 raised to the 3 halves X. And this says approximately what percent of water remains per minute. So first thing we have to determine is this exponential growth or is it decay? And how do we figure that out? That is correct. We have to look at the number inside the parentheses. So when we look at that number inside the parentheses, we can see that it is less than, so remember if it's less than 1, then it is exponential decay. So we're dealing with the y is equal to c, and then we have our parentheses 1 minus r to the t. Remember, the most important area of these problems is this 1 minus r. So whenever we're trying to find the percent rate, we're dealing with the 1 minus r area. But the problem is that we have a number in front of our x term or in front of our time. So that's when we have to take that inside of the parentheses, 0.84, and raise it to that power. So now we have 0.84 to the 3 halves raised to the t. So we're going to use our calculator. We're going to put in 0.84. We're going to raise it, alpha y equals for the fraction, to the 3 halves. And we get our new number that will be in that inside area. So we have 0.7699. So we have 0.7699 raised to the t, and we have the 450 on the outside. And actually in this problem they use x, so I'll put an x in this we have. And so from here, remember this 0.769 is that 1 minus r. So we subtract our 1. Bam, bam. So on this side we have our negative r. Then we take our calculator and we're going to subtract 1, so minus 1. And we get the negative 0.2301. So we get negative 0.2301. We still have to divide by negative 1 because r needs to be positive. So we get 0.2301. And then we have to multiply by 100. And when we multiply by 100, we get the 23.01%. And that is our rate of decay. Alright, so just to go through the steps again, remember the first thing we did? Well, the first thing we did was to make sure that there's no number in front of our x. Then after that, we simply subtract 1. The second thing we did was divide by negative 1. The third thing we did was multiply by 100. Now we have to be careful because they did not ask what percent was decaying. They asked what percent of water remains per minute. So think about this. Think about we have a little pot. We have a little pot. We have a little fire. So the fire's there. And what's happened, we have water in here, but as time goes by, remember from your science class, some of it evaporates. And that part that is evaporating, we're losing 23.0% every minute. So how do we figure out if 23.01% is going away? How do we figure out what amount is remaining? That is correct. We just subtract 100. So when we take 100 minus the 23.01%, we will get our answer. So we take 100 and we subtract the 23.01, we will get our answer, which would be the 0.99. Bam. So 76.99% of the water would remain every minute. Alright, so there's really nothing different about these problems that we did. We just want to make sure that we fully understand what is going on. We want to make sure that we're always answering the question. So again, if you need to, you can rewind this video so you can get a better understanding of what occurred, or you can go back to video 1 or video 2. Again, I really hope this video helped.